Alright guys, welcome to day 6 of our Unit 3 notes on rational expressions and equations. Today we're going to focus on word problems that involve rational equations to solve. So first question, does there exist a pair of consecutive even integers whose sum, or whose reciprocal sum to 5/12? If so, what are they? So first of all, consecutive even integers would be like 2, 4, 6, 8. Who do we appreciate? So they have a difference of 2 every time. So bringing it back to Algebra 1, let's think of our let statements. Let's let x equal our first number. If they have a difference of 2, x plus 2 would be your second number. Now, reciprocals mean just to flip them. So this would be 1 over x and 1 over x plus 2. Sum means to add. So the sum of the reciprocals is equal to 5/12. All right, we're all set up to solve. Now this is like what we did on day 5. Look at your denominators and decide on a common one. So my common denominator would be 12x, x plus 2. So I just took one of each of them. So that means that this denominator who has an x, he would need a 12 and an x plus 2. And whatever you do in the bottom, you have to do to the top as well. Second one has an x plus 2, which means he needs a 12x. And then this would be x and x plus 2. Now, once you have decided on your common denominator and adjusted all your numerators, when the problem equates, you can drop the base and solve the numerator. So you have 12 times x plus 2 times 1 plus 12x times 1 equals 5x times x plus 2. So again, I just looked at my numerator there. So let's go ahead and solve. 12x plus 24 plus 12x equals 5x squared plus 10x. So 24x plus 24 equals 5x squared plus 10x. All right, so I've cleaned up a little bit of the equation. Keep in mind it's a quadratic, so I should set it equal to 0 to solve. So if I subtract the 24x, I would have 5x squared minus 14x minus 24. Now, I might be able to factor this, but I'm also thinking this is a good opportunity to review our quadratic formula. So, where I have some space, I'll come like over here. Oops. X equals negative b plus or minus the square root of b squared, which 14 squared is 196, b squared minus 4ac all over 2a. Let's grab our calculator. All right, so let's clean up the discriminant. That's the stuff under the radical. So 196 minus 4 times 5 times negative 24. And I get 676. All right, let's check. Is 676 a perfect square? Second square root. Go up and grab that. And look at that, 26. So this works out pretty nicely. X is equal to 14 plus or minus 26 divided by 10. All right, let's figure out our two solutions. So I've got 14 plus 26 divided by 10. And remember, we got to do the same thing, but then minus. All right, so I'm getting 4 and negative 6/5. All right, now remember what you were looking for. You're looking for consecutive even integers. -6/5 is not an integer. So that rejects. So 4 would be my first integer. 6 would have to then be my second consecutive even integer. Now let's see, does that make sense? If I do 1/4 plus 1/6, those are the reciprocals, right? Math bracket. I get 5/12, which is exactly what I was hoping for. And that's the first word problem. Now, the second type of word problem is working together problems, where the idea is individual plus individual equals total effort together. So suppose Huck can paint a fence in 5 hours. If Tom helps him paint the fence, they can do it in 3 hours. How long would it take for Tom to paint the fence by himself? So I highlighted some important information. Huck is taking 5 hours. So let's write that as 1/5. So it's one job completed in 5 hours. Tom is what I'm solving for. I don't know by himself, so let's call him 1/x. But their effort together was 3 hours. Okay, so it's always one job over however much time it would take. So in this case, hours. Now, it makes sense that Huck plus Tom equals together, right? So we're going to do 1/5 plus 1/x equals 1/3. Now you're all set up to solve like we are in the previous problem. Whoops. Okay, now your common denominator would be a good 15x, which means first guy needs a 3x, second guy needs a 15, and last guy needs a 5x. Okay, now when the problem equates, you can drop the base and solve the numerator. So I have 3x plus 15 equals, now keep in mind that was 1 times 5x. So subtract the 3x, 15 equals 2x divided by 2. X would have to be 7.5. So Tom takes a little bit longer than Huck, but you know what? He's trying his best and he's helping us get the job done in 3 hours then. All right, so same idea. If one clerk takes 20 minutes to sort the mail, and a second clerk takes 30 minutes to do the same job, how many minutes will it take both clerks working together to sort the mail? So we've got clerk 1 taking 20 minutes, clerk 2 took 30, and together we don't know. So 1/20 plus 1/30 equals 1/x. Now, as far as a common denominator goes, you could really multiply them all together and use 600x. I'm personally recognizing that I could take 20 and turn him into a 60 just as easily as I could take 30 and turn him into a 60. So I'm personally going to use 60x, but you could use 600x as well. Your numbers would just be bigger. So that means the first guy would need a 3x. Second guy would need a 2x in order to create a 60x. Last fraction needs a 60. When the problem equates, you can drop the base and solve the numerator. So I have 3x times 1 plus 12. Oops, excuse me. I got to be careful with my multiplication. That's 1 times 2x, which is 2x, equals 1 times 60, which is 60. 5x equals 60. So x equals 12. It would take them 12 minutes together in order to sort the mail. All right, so hopefully you're feeling this is pretty easy. This actually has shown up on the exam in the past. So not too bad of a problem. Once you set it up, not too bad. All right, question 5. Bob and Ted are electricians. Why did I highlight that? That's fine. Bob and Ted are electricians. When they work together, Bob and Ted can install new wiring in 15 hours. if Ted works alone, he needs 16 more hours to do the job than Bob needs when he works alone. Find the amount of time Bob needs to install the wiring when working alone. Okay, so first of all, they're giving me the together first. Together, they can do the job in 15 hours. Now, this is where it gets tricky. You got Ted and Bob. If Ted works alone, he needs 16 more hours to do this job than Bob needs when Bob works alone. So notice how everything's based on Bob. So let's call Bob X. If Ted needs 16 more hours, that means you need X plus 16 to be the denominator. Now, be careful, it's not 16 times X because that would be 16 times more hours, and that would be insane. All right, so Ted plus Bob equals together. And I'm just going to use one of each of those as my denominator. So 15x times x plus 16. All right, first guy would need a 15x. Second guy would need a 15x plus 16. Last guy needs an x and an x plus 16. So I'm just multiplying by whatever the denominator is lacking, and then remember, whatever you do to the bottom, you have to also do to the top. When the problem equates, we can drop the base and solve the numerator. So I have 15x times 1 plus 1 times 15 times x plus 16 equals x times x plus 16, because it was times 1. All right, clean this up. Uh, 16 times 15 is 240. X squared plus 16x. All right, let's clean this up a little bit. It's a quadratic, so let's set it equal to 0. I have 16, but I got to subtract that 30 from the other side of the equation. So minus 14x, and then subtract the 240. So again, this was 30x together, and then I did 16x minus 30 to get the minus 14. All right, now I might want to use my calculator to help with the factors here. So y equals 240 divided by x. Oops, didn't mean to do that. Second. There we go. All right, so I need to have factors of 240 that have some relationship with 14. So maybe I could do a negative 24 and a positive 10, because those would multiply to negative 240 and then add to negative 14. So 10 and 24. Okay, minus plus x equals negative 10. X equals 24. Now remember, x is representing Bob's time. Is Bob going to take negative 10 hours? No, that doesn't make sense. So we reject the negative 10. Could Bob take 24 hours? It's a long time, but that's how long Bob takes. So it says find the amount of time Bob needs. Bob needs 24 hours. Now, in theory, I could say, how long does it take Ted? Well, you know Ted is just 24 plus 16, so, actually, Ted's worse, right? So Ted would technically take 40 hours. Not that I asked for it, but, I could. All right, question 5. Working together, it takes Sam, Jenna, and Francisco 2 hours to paint a room, or 2 hours to paint one room. All right, so you got all the people together taking 2 hours. When Sam is working alone, she can paint the room in 6 hours. When Jenna works alone, she can paint one room in 4 hours. Determine how long it takes Francisco to paint the room on his own. So guys, it's the same thing. You've got Sam working in 6 hours, Jenna working in 4 hours. We don't know Francisco, but we know together they can do the job in 2 hours. So rather than having individual plus individual equals together, you just have 3 individuals. No big deal. Add these all together. So 1 over 6 plus 1 over 4 plus 1 over x equals 1 over 2. And then a common denominator I could use is 12x. I could have used 24x. I could have even done 48x. Okay? I just went with my lowest common denominator, but you can really just multiply those all together and that would work as well. So with that being said, I could multiply the first fraction by 2x, second fraction by 3x, again to create my 12x, 12 to multiply to get 12x, and then lastly 6x. When the problem equates, you can drop the base and solve the numerator. So I have 2x plus 3x plus 12 equals 6x. So 5x plus 12 equals 6x. This is pretty easy, so 12 equals x. So Francisco is kind of the slowest painter. It takes him half a day, but you know what? Maybe he does a really nice job. So Francisco takes 12 hours. All right, here is our last problem of the day. Courtney, Emily, and Melissa are frosting 3 dozen cookies. Working by herself, Melissa can frost her cookies twice as fast as Emily. Independently, Courtney will finish frosting the cookies in 2 hours. When they work together, they can complete the job in 1 hour. How long will it take Emily to frost the cookies by herself? Emily, Courtney, Melissa, together. All right, working by herself, Melissa can frost the cookies twice as fast as Emily. So let's actually do this. You got to think to yourself, if x is the amount of time, Melissa is x, Emily is taking twice as long as Melissa. So think about it not so much as twice as fast, because then technically Emily would be x and Melissa would be half of x, and that's kind of awkward. If Melissa is twice as fast as Emily, then Emily is twice as slow as Melissa. If Melissa takes 2 hours, Emily's taking 4. If Melissa's taking 5 hours, Emily's taking 10. So try to keep that in mind. Courtney's doing it in 2 hours, so she's 1 over 2. Now together, they're doing it in 1 hour. So let's just call that 1 over 1. So again, it's one job completed in 1 hour. Now just like the last problem, I take all 3 individuals and add them together. So 1 over 2x plus 1 over 2 plus 1 over x equals 1 over 1. Now my common denominator would probably be 2x. I think that's the easiest denominator to use, because then I can easily say, well, I'm going to multiply the second one by x, the third one by 2, and then the together part is going to have to be 2x. When the problem equates, you can drop the base and solve the numerator. I'm hoping if I say that enough times, it will stick with you guys. All right, so I've got 1 plus x plus 2 equals 2x. So 3 plus x equals 2x, so 3 equals x. So again, keep in mind, x is representing Melissa. Melissa is taking 3 hours. So how long would it take Emily? She's taking 6 hours because she's double the amount that Melissa is doing. But you know what? She's trying her best. She's doing her best, and that's all we can ask for. And that, my friends, is working together problems. So hopefully you felt this was pretty easy. This is usually a pretty good lesson. Good luck on the homework.